Okay guys, Assalamu alaikum. Uh, this is the first question in worksheet 1A. It's a parametric curve. Parametric curve means that x is related to t, y is related to t, and you need to relate them together and sketching the curve. So what you're trying to do here is to have the cosine by itself, so you divide by 3. And you divide the y by 2 to have the sine by itself. Then you square everything. Squaring this, it would be x squared over 9 cosine squared. Squaring this would be y squared over 4. After you squaring everything, you add everything. You add this to this, so it'll be x squared over 9 plus y squared over 4. And you add this to this, so it'll be cosine squared plus sine squared. And x squared over 9, y squared over 4, you know cosine squared plus sine squared is 1. When you see something like this, where it's x squared y squared added equals 1, but the number is different, this would look like an ellipse. It would look like an egg, either this way or this way. Now to figure out how you can sketch this, you go like this, you put x, y, so 1, 2, 3, -1, -2, -3, 1, 2, 3, -1, -2, -3. Now, for the x, this is the x. The number here is 9, and the square root of 9 is 3. So in the x, you go 3 and -3. For the y, the number here is 4. And the square root of 4 is 2. So in the y, you go 2, -2, and that's your egg or ellipse. This is the first question. The question 2 in your worksheet 1A you have a parametric curve x squared t squared minus 2t and y equals t squared. You're asked to find the derivative of y with respect to t. So derivative of this is 2t. You're also asked to find the derivative of x with respect to t, and the derivative, as you guys know, is 2t minus 2. And use this information to sketch the curve. So we need to sketch the curve. Now, sketching this curve, we'll leave that for now. I'll tell you later what we can do to sketch the curve. I'll leave space for this. In the B question, find the tangent at 2. Tangent at 2. Now to find the tangent at 2, anytime you do a tangent, you need x star, y star, m. So at 2, you put the 2 into this. That would be 2 squared minus 2 times 2, so your x0. Y star, you put the 2 into this. That would be 2 squared, 4. And for m, you put it and this one over this one. So you need dy over dx. So you divide the 2t minus 2, and here you put the 2. If you put the 2 here, it would be 4, and the 2 here would be 4 minus 2, 2. That's a 2. Once you have the three things here, you put everything in the general equation. Y minus y star equals mx minus x star. So it would be y minus 4, 2x minus 0. You can leave it like this. You can work it out and say this is like 2x plus 4. Okay, this is how you find the tangent line. Now, for the idea of sketching, now, there's no specific way to help you sketch a parametric curve, so it's always recommended that you actually plug some points. So you could do this. You have x, y, and t. You can do a minus 2, a minus 1, a 0, a 1, 2, and see what you get. A minus 2 here will give you 4 plus 4, 8. A minus 1 will give you 1 plus 2, 3. A 0 will give you a 0. A 1 will give you 1 minus 2 minus 1, and a 2 will give you a 0. If you plug it here, minus 2 squared is 4, 1, 0, 1, and 4. You can also use the fact that these are the derivatives. If you set dy over dt to 0, you get what's called horizontal tangent. So 2t equals 0, meaning t equals 0, we have a horizontal tangent. So this point here, 0, 0, that's a horizontal tangent. And if you set dx over dt to 0, you get a vertical tangent. So 2t minus 2 equals 0, 2t equals 2, t is 1. So this point here is a vertical tangent. So I'm going to use the information in the table here to help me sketch. So I'm going to erase this. This is my y, this is my x. X, I need, say, 1, 2, 3, 4, 5, 6, 7, 8. Minus 1, minus 2, minus 3, minus 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, negative 4, negative 5. So we start with the point 84. We need 3, 1, 0, 0, negative 1 and 1, 0, 4. And remember, this one is a horizontal tangent, meaning that the curve must look like this, so it's horizontal tangent. This is vertical, so the curve has to look like this, so it's vertical tangent. So the curve looks like it's going to go like this. Sorry. It's like this, making this a vertical tangent, going to this one and going like that. Sorry if it's not very clear, but it's like going this way and going like that. Good? Now, there's also part C for the question. And find the area under the curve when you go from 0 to 1. Area 0 to 1. Now, under a parametric curve, the area formula that we actually use is you go from A to B, y dx. Well, of course, dx over dt. So they want you to go from 0 to 1. You put the y equation, and you put dx, which is 2t minus 2 dt. Now you get this inside 2t cubed, 2t squared. You integrate, you integrate 4 over 4, 3 over 3, you put 1 and 0. 1 will give you 2 over 4, which is half, and 1 here will give you 2/3, and 0 will be 0. So the answer is half minus 2/3. And if you want to put it as one fraction, this is like 3 over 6 minus 4 over 6 minus 1 over 6. That's if you want to do it as one fraction. So this is the first two questions. I'm gonna stop this video. This is only part 1. Part 2, I'll do question 3 and 4. Thank you.